Okay, let's have a look at question 3c. Bit of a trickier one, actually. It has a little bit of a twist to it over here, which you have to kind of pay attention to, really. So, first of all, we've got a couple of points here, and we don't really have to worry too much about the values of those points. The main thing about those points is we can see that we have a positive parabola, therefore we're going to have a positive cubic. Now, positive cubic, of course, is going to look something like this, yeah? It's going to look that way around. So this point here must be the positive part. Now, we don't actually know what it looks like, but we've got one clue here, and that's h of a is 0. Now, this is the graph, of course, of h of x. So the cubic itself will be, h prime x, this is h prime x. We want to find h of x. So h of x is going to be, and we can just draw roughly what it's going to be. So this along this line here, and you could probably put a dotted line along here, but you're going to have something where this is going to be here, the turning point. And that's the first thing you're going to draw. So you've got your turning point there, and as you've got your turning point, it's going to come around here, and it's going to head down. Now, the thing about it heading down is we do know something about this point here, and that is when we find the integral of this thing here, and then we can roughly do the integral, by the way, because we know that this is, let's call that -4. So we've got x minus 4, or sorry, x plus 4, and this is going to be a 2, which is x minus 2, and we'll make it equal to 0, so we can solve it. So if we expand this out, we're going to get x squared minus 8, then we've got a 4x minus 2x is going to be a plus 2x. So that is our y, or in fact, let's call it what it really is, which is, that's h prime x. Here we go, h prime x. There it is. Now let's make it, though, h of x. Now h of x, though, is going to be the integral of this, which is going to be x to the 3 on 3 plus 2x 2 on 2 minus 8x1 on 1 plus c. Let's tidy that up just a little bit. And we're just really playing with this here because we don't know if it looks like that. But we've got roughly 1/3 x cubed plus this is going to come to x squared minus 8x plus c. Now, there's our cubic, roughly, kind of, sort of, who knows. But we're not really we're interested in plotting that, because we've got this h of a equals 0. Now, this is an interesting little twist here. And it's interesting because if we were to plug in as h here, and we'll play h of x as that, and we were to put an a in here, let's just do that now. So h of a is equal to, therefore, 1/3 of x, sorry, 1/3, oh crikey, I almost put x cubed there, 1/3, and that's going to be a cubed plus a squared minus 8 times a plus c, yeah? And we know all of that is equal to 0, because really h of a, this is the same as saying y equals 1/3, blah, 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 yeah? Now, I suppose the importance of that is really what we're saying is when x equals a, y, that's y, that thing's there, y is equal to 0. Y equals 0. So my x value is a. There it is. My x value is a. Now, I've gone along x. How far do I go up? Well, I go up 0. So I've got a coordinate here, which is going to be a along and 0 up. And so let's do that now. So we're going to go a along and 0 up. So there it is. In other words, it's going to touch that point and it's going to turn at that point. Here we go. So it touches, turns, and heads back up. Now that, by the way, is a terrible graph, but you get the idea. So the coordinate here is a, 0. Yeah? When x is a, y is 0. And of course, we know it must turn at that point because it must turn where the x-intercepts are. It must turn here, there it is, must turn here, there it is. And we know that when x is a, y must be 0, so therefore it turns there and into at the intercept, if you like, it just touches momentarily that particular point. So that would be how I would draw that graph.